So students will use exponent rules to simplify expressions. Let's go ahead and talk about your exponent. And you don't have to write all this down. We'll go through and we'll talk about each rule individually. But we're starting out with, what do you do when you have a negative exponent? What do you do when you have a fraction raised to a negative exponent? What about anything to the 0 power? And then you've got these other basic rules that you've been doing probably since algebra, pre-algebra. And we're going to go through each of these one at a time and make sure that you remember them. Okay, let's start out. We'll just scroll down right here and look at some examples of each. Let's start out with negative exponents. That's a negative. 2 to the negative 3 power. Your rule is, anytime that you're exposed to a negative exponent, anytime you have a negative exponent, all you need is a fraction bar, because we really don't understand negative exponents, really don't know how to work with negative exponents. So the rule one, what we want to do is make a negative exponent positive. Anytime you have a negative exponent, create a fraction bar if you don't already have one. Anytime a negative exponent is moved across a fraction bar, it automatically becomes positive. Just the exponent, not the number that's being, or the base being raised to that exponent. So 2 to the negative 3, when brought to the bottom of a fraction, becomes 2 to the positive 3. So now you've got 1/8. So 2 to the negative 3 power is an 8. If it's on bottom, if you've already got a fraction bar, if it's on bottom, bring it to the top. Anytime that top or bottom is left void, you can put a 1 there. So 1/4 to the negative 2 power is the same thing as 4 to the second power over 1, or just 16. Now here's where you want to start. Here's where people make mistakes. Don't do this. 2 to the negative 3 plus 3 to the negative 2. One big solid fraction bar under the whole thing. What people are going to want to do is do that and bring it to the bottom. Can't. Okay? Anytime you throw in that addition and subtraction, you're dealing with two completely separate entities. Okay? Anytime you've got a plus or a minus sign, what you've got to do, if I can erase, no, it doesn't work, is separate. Okay? Write them as two separate fraction bars. Okay? Not one solid one, two separate. So now you've got 2 to the negative 3 comes to the bottom of this one and becomes 2 to the positive 3 on bottom. 3 to the negative 2 becomes 3 to the positive 2 on the bottom of that, which would be a 9. So this is actually 1/8 plus 1/9. 2 to the negative 3 plus 3 to the negative 2, it's adding fractions, is what that is. And you can multiply, find common denominator. I'm more interested in this part. I believe you would get 18 over 72. So right, 9, that's 17 over 72. Next up, what do you do if you have a fraction raised to a negative exponent? 2/3 being raised to a negative 2. Okay, first way is a long way. You can write it out if you want to, but I wouldn't. I'd wait for the shortcut. The rule is, and we're fixing to go over it, anytime you've got a fraction, let's say a over b to the nth power. Anytime a fraction is being raised to a power, every bit of that fraction is being raised to that power. So what you can actually do is split that up and say, well, that's a to the nth power over b to the nth power. You can raise them both to that power. It's very similar to the distributive property. Same thing here, 2 over 3 to the negative 2. This is the long way. I could say that's 2 to the negative 2 over 3 to the negative 2. Since they're both negative exponents, this one's on bottom, I got to bring it to the top to make it positive. This one's on top, I got to bring it to the bottom to make it positive. So I have now 3 to the positive 2 on top. I've got 2 to the positive 2 on bottom, which would be a 9 and a 4. That's the long way. What's the short way? What could I have done to begin with? When you distribute that negative, do you not know that both of them is going to be negative? Why not go ahead and flip it to begin with? You see that? Because your 2 is going to end up on bottom. Why? Because it's raised to a negative. Your 3 is going to end up on top because it's raised to a negative. So easy way, if a fraction is raised to a negative exponent, go ahead and to begin with, flip it and change the negative to a positive. 2 over 3 to the negative 2 power, a fraction raised to a negative, flip it and make it a positive. Now you got 3 to the second, 2 to the second, 2 to the second, that's 9 over 4. Some of you will be able to do that in your head. Some of you will say, well, since that's a negative power, go ahead and flip it. That's a 3 and a 2 raised to the positive 2, and you'll go ahead and distribute it out in your head. Anything to the 0 power? Remind me. What is it? Thank you. 1. What does everybody always put? 0.
Miss Turner, come to the office, please.
Your next rule, anytime you have the same base and you're multiplying exponents, think of it like this. You have 3 times 3 times 3 times 3 times 3. That's 5 3's being multiplied together. Anytime the bases are the same, you add exponents. X squared y to the 4th to the 3rd power. These are the two that people get mixed up. That one and this one. When do you add exponents? When do you multiply exponents? Here's how to think of this. All of this stuff, there's 3 of them. X squared, there's 3 of them. Y to the 4th, there's 3 of them. That's what to the 3rd power means. So you have technically x squared, x squared, x squared. That goes back to this rule. If it's x squared, x squared, x squared, add all those x's together. How many do you have? I believe that's 6. What's the easy way of doing that? Anytime a power is raised to another power, multiply the powers together. Again, anytime a power is raised to another power, simply multiply powers. If powers, same bases are being multiplied, add powers. If a power is being raised to another power, multiply powers. This next, what I'm about to say, this is just error control. Make sure you don't do this. And hopefully, we're about to talk about it later on in the chapter. And hopefully you remember why you can't just do this. As soon as you throw, okay, look at this problem, look at this problem. As soon as you throw that plus or minus sign in between, okay, this is what's called a monomial. There's one term. There's no pluses, there's no minuses. Just that one thing is being raised to the 3rd power. As soon as you throw that plus or minus in there, this is what's called a binomial. It's got 2 terms inside that parentheses. To square that, you can't just say x squared plus y squared. A lot of people will do that. Okay, that's one of the main mistakes when you're multiplying these things out. That's one of the main mistakes that people make. So please make sure as soon as you see that plus or minus sign, and I'm not going to get ahead of myself, but that's x plus y times x plus y. You have to boil it out. X times x, x times y times x, y times x. Okay? We'll get to those later. Nearly done with our rules for exponents. Let's do one more. Let's say you've got x to the 5th over x to the 2nd. Here's how I want you to think of this rule. You've got 5 x's on top. There's just 2 on bottom. You've got canceling happens. It's like a 5 over 5. They cancel each other out. That's 1. One of the x's cancels with one of the x's on bottom. Another one of the x's cancels with another one of the x's on bottom. You've got 3 left. If there's 5 on top, 2 on bottom, they're going to cancel each other out. You're going to be left with 3 on top. A lot of people say, well, the rule is just subtract. Okay, 5 minus, that's fine. Okay, but here's the reason I want you to also think of it like this. What if there's more on bottom? X to the 7th over x to the 10th. You have 7 x's on top, you have 10 x's on bottom. Start canceling them out. Every x on top is going to cancel. Most of the x's on bottom are going to cancel, but you're going to be left with some on bottom. Now, can we subtract here? Yes. There's 2 different ways to work this problem. Most of you, a lot of you, just subtract from top down. You'll do 7 minus 10. You'll say that's x to the negative 3 power. There's a quicker way. Why not just take the bigger one, say, well, there's more on bottom. Subtract it from bottom to top. Say, well, since there's 10 on bottom, 7 on top, when I subtract those off, I'm going to be left with 3, but those 3 are going to be on bottom still. There's nothing left on top, so put your 1 there. Don't put a 0. Now, does that go along with a 7 minus 10 x to the negative 3? Yes. Because if it's a negative exponent, what do? Put a fraction bar under it, bring it to the bottom. Now it's a positive. So both answers check out. Okay, let's work the problem. 3 to the negative 1 times 5 to the negative 2 times 10 to the positive 2. Again, we have all multiplication. We can do a solid fraction bar. What I cautioned you on is if these things are being added or subtracted, no. Do separate fraction bars. The stuff that's negative, the stuff that's being raised to negatives, bring that to the bottom. Help me out, Noah. 10 to the positive 2 stays on top, Noah. What is 10 to the positive 2? 100. So we got 100 on top. Jordan, 3 to the negative 1 comes to the bottom. What does it become when it's on bottom? 3 to the first, or just 3. What about 5 to the negative 2? What does it become? Careful. Which is 25. So we have 3 times 25. Let's go ahead and multiply that out. We have 75 on bottom. Y'all are growing up on me. I'm going to skip a lot of steps. And if I do ever skip a step and you're like, where did that come from, please ask. But again, 3 to the negative 1 became 3. 5 to the negative 2 became 5 to the positive 2, which is 25. So now you have 3 times 25 on bottom, or 75. Reduce your fractions. Divide top by 25, divide bottom by 25. That would be 4/3. So here we go. 2 over 3 to the negative 3 power. Again, anytime there's a fraction raised to a negative exponent, let's go ahead and flip that fraction first. 3 is now on top, 2 is now on bottom. It's now being raised to the positive 3 power. Help me out with that next step, Trevor. 3 to the third. And again, here's the mistake. A lot of people is going to want to do 3 times 3. A lot of people is going to want to do 2 times 3 on bottom. Make sure you're raising it to the third power instead of multiplying it. So, Trevor, what's 3 to the third? Good. And what's 2 to the third? And that looks so much like it should reduce, but it won't. 27 over 8. Fraction raised to a negative, flip it. I'm not going to work this one. Bring 6 to the negative 2 to the bottom, make it positive. Bring 2 to the negative 3 to the top, make it positive. Okay. And then just multiply it out. Multiple things in parentheses. Guys, this is 6 things. There are 6 things in parentheses. All 6 of those things are being multiplied together. That's all this is. You're kind of multiplying like terms. Savannah, what can I multiply the 3 by? Not x to the 8th, that's nothing alike. Not y to the 2nd. What could I multiply 3 by? The negative 2. What do you get? Good. So we have negative 6. Skyla, x to the 8th. I need to combine that with this x over here. How many x's do I now have? Good. So negative 6x to the 9th. Daniel, I have 2 y's here. I have 4 more y's here, which gives me a total of 6 y's. Done. Again, don't get it confused with if it's a power raised to a power, you multiply the powers. If you're combining multiple y's or multiple x's as we do here, you just add them together. 2 here, 4 here, total of 6. Two to the third times 3 to the second. I put this problem on here for this reason. I saw this in the book, and so many people is going to look at that and they're going to try their best to find some sort of exponent rule. Here's my advice. No matter how high you get in mathematics, don't overcomplicate things. We tend to do that. I have in here the elite of section high school, and a lot of times as being, once we get to that point where, we just, look at all these hard maths that I take now. We'll look at stuff like that and we'll try our best to find some sort of exponent rule. We'll try our best to find some sort of way to combine like terms. Just raise it to a power, multiply together. Okay? Don't overcomplicate things. There might be 50 different ways to go at a problem. This one is pretty straightforward. 2 to the third power is 8. 3 to the second power is 9. 8 times 9 is 72. You're done. Okay? That's all you have to do there. So don't overcomplicate things. We'll work this one. Just because I've got some negative. It looks similar to the problem we worked a while ago, but we got some negative exponents thrown in there, so let's try this one. Allie, what can I multiply 3 by? Good. And it gives you negative 12, good. I have 2x's here, and I have negative 2x's here. Now, a lot of people, and there's two different ways to go with this problem. A lot of people, as soon as they saw these negative exponents, drew a line underneath, brought them to the bottom. Do I need two separate lines? No, there's no plus signs, minus signs. You could draw one continuous line under this entire problem. And you could go ahead and bring that x to the negative 2 and y to the negative 5 to the bottom. That's fine. Okay, if you want to work it like that. I wouldn't. If I'm multiplying out x's, I'm multiplying out y's, I'm combining those. I combine those by adding or subtracting in this case. I have x to the positive 2. I've got to combine it with x to the negative 2, so I've got to add those together. Abby, what is 2 and negative 2? 0. How many x's do I have? 0. Think about it if you worked it the other way. If you drew the line underneath that brought the x to the negative 2 to the bottom, you've got x to the second on top, you've got x to the second on bottom. Do they not cancel out anyway? So either way you work it, you have 0 x's. You have 3 y's, you have negative 5 y's. Help me with that part, Logan. What's 3 and negative 5? Add those together for me. So we'll have y to the negative 2. Or again, you could have thought of it as this. Bring the y to the bottom. You've got 5 y's on bottom, you have 3 y's on top. You're left with 2 y's on bottom. How do I leave my answer? Make sure, if at all possible, leave your exponents. That's a negative 12. Make sure that you leave your exponents as positive exponents. We want to try to stay away from negative exponents if at all possible. So don't leave your answer like this. I mean, that is an answer. So many people get bogged down with, I don't know when to stop. That's an answer. I would rather have it here just because we don't have any more negative exponents. And if I showed a ninth grader this, I think they would be more comfortable here than here. So leave your answers with positive exponents. We're getting there. Elizabeth, these things are being divided. On top I have a negative 6, and I believe I can combine that with that positive 2 on bottom. Divide those out. That's all that bar means, right? Anytime you see a fraction bar, I think I've showed y'all this before. What does a fraction bar mean? Where does the actual division symbol come from? The division symbol is a fraction bar. I don't know if you've ever noticed that, right? You see that? What are the dots? The dots in a division bar represent numbers. So you have something over something, or that means divide. So we got a fraction bar. We're going to divide it. Elizabeth, what's negative 6 divided by 2? And where do we put it? That's the question. I divide it from top down. Let's put it on top. Can you divide from the bottom up? Look at this. Let me show you something. This is completely off subject, but look at 2 over 6. Can you divide from the bottom up? Yes, as long as you put your answer where. 2 over 6, what is 2 over 6? 6 divided by 2 is 3. If you put that answer on bottom, nothing's left on top. Is that the same thing as a third? You can't. As long as, if you're going to divide from bottom up, make sure you put your answer on bottom. We have 5 A's on top, 7 A's on bottom. Lydia, start canceling. If there's 5 on top, 7 on bottom, where am I going to have extra A's at? You do the A to the negative 2. Okay, think of it like this. And that's right. You can put A to the negative 2 on top. Or think, I've got 7 A's on bottom, I've got 5 on top. Start marking them out. I'm going to mark out every one of these, right? And she said when she subtracted, you're going to mark out all but 2, because when you subtract, there's going to be 2 left. But those extra 2 A's are going to be on bottom, which is the same thing as A to the negative 2. That's right. Last one. Let's see if we can do this in our head. Let's stretch our brain a little bit this morning. Avery. Good. I have B to the negative 3 on bottom. Bring it to the top. At the same time, I have B to the negative 1 on top. Bring it to the bottom. I have 3 on top. I have 1 on bottom. If any of you need to see that. After I move them, that's what I have. As I cancel them, the 1 on bottom cancels with one of them on top. Subtract it. There's more on top, so you're left with, like you said, B squared on top. All my exponents are positive. All my numbers are divided, reduced as far as it can go. Done. Negative 3B squared over A squared. They're just getting more fun and more fun as we go. This is what freaks people out. Let's see stuff like that. A minus 5 on top, or raised as an exponent. How do you bring that to the bottom? Just side note. What if that's your fraction? X to the a minus 5 power. Is that a positive or a negative exponent? Trick question. Is that exponent positive or negative? What's a? We don't know, right? What if a is 6? Positive or negative exponent? Positive. What if a is 4? Positive or negative? Negative. So what is a to minus 5? It can be both. Could that power, could that expression be brought to the bottom of a fraction? Yes. How would you do it? What would that power be? Make y'all think a little bit this morning. What would that power be? That'd be 1 over x to a power. What would the power be on bottom? It's an a minus 5 power on top. Close. Very close. If it's x to the negative 3 on top, it's x to the positive 3 on bottom. If it's x to the positive 3 on top, it's x to the negative 3 on bottom. When you move it across, you change the sign, right? That's exactly it. It'll be a negative a plus 5. You would change both signs. Something else I would like to remind you, and I'll be just giving you these tidbits as we go. Something else I'd like to remind you, negative a plus 5, all through middle school, teachers told you that subtraction was not commutative. And when I say commutative, let me remind you about commutative property. 2 plus 3 is the same thing as 3 plus 2. That's commutative property. It can be moved around. And everybody always said the subtraction property is not commutative, which is true to an extent. 2 minus 1 is not the same thing as 1 minus 2. But 2 minus 1 can be written, that's a positive 2, right? 2 minus 1 can be written as a negative 1 plus 2. You can use commutative property as long as the sign stays with the number. That 1's negative, that 2's positive. I could put the negative 1 first and the positive 2 second. You still get the same answer. So that commutative property does kind of apply. So this negative a plus 5, if you don't like negatives, if you'd like to, you could write that as 5 minus a. So x to the a minus 5, if you bring it to the bottom, will be x to the 5 minus a. You could kind of flip them around as well. But back to this problem. Everything's being raised to the 4th power. There are 3 things inside parentheses. All 3 of those things are being raised to the 4th power. Brianna, can you raise negative 3 to the 4th power for me? Careful. Don't multiply. Raise to a power. Negative 3 times negative 3 times negative 3 times negative 3. While you're thinking, I'm going to write it down. And I'll show you a hint here. Here you go, Brianna. Group them together. Anytime you're, especially 4th power, 6th power, something like that, group them into groups. That's 9 times 9. That's all it is. 81. We've got to raise, Brett, we've got to somehow raise x to the a minus 5 to the 4th power. There you go. I have no idea how to do it. I really do. But if you're saying to yourself, I have no clue how to do that, here's what you need to do. If you've got something ugly as an exponent, come to the side and say, well, let's make up a problem that's easier. What if it was x squared raised to the 4th power? What would you do there, Brett? X squared to the 4th. That'd be x to the 8. Not x to the 6. A lot of people want to add that. That's x power to power multiply. So what do I do? I just got to multiply those. Make up a problem that's simple, that's just like that problem. So Brett, multiply that. That'd be x to the negative 6. Multiply this by 4. There you go. 4a minus 20. Power to power, multiply the powers. A to the 4a, or excuse me, x to the 4a minus 20 power. And that would be y to the, I'm going to go ahead and save ourselves a step. That's y to the negative 12th. Since it's negative, move it to the bottom. Save some paper. There you here we're combining some of our rules together. We have ugly stuff to the negative 3 power. It doesn't matter what's inside. It's a fraction. Now what does matter is I see absolutely no pluses or minuses there. As soon as you throw pluses and minuses into if I put a plus between 3 and a there, this problem becomes so much more difficult. Because then you're dealing with like FOIL. You're multiplying stuff out. But these, as long as it's one term inside there, pretty easy. Not easy, easier. First thing that you need to think about, you have a fraction to a negative exponent. Colby, anytime you have a fraction to the negative exponent, what do you need to do to that fraction? Thank you. So 2a to the negative 3m is now on top. 3a to the 2m minus 1 is now on bottom. And it's now being raised to the positive 3 power. Any questions so far? Anna Marie, 2 and 3. Can you do anything with 2 and 3? Is it reducible? Is it dividable? Or is it in simplest terms? 2 and 3? Yeah, because if you divide that, anybody right off the top of your head know what 2 divided by 3 is? 0.6 repeating. You don't want to do that. I like 2 and 3. I don't like 0.6 repeating. Let's leave 2, let's leave 3. Okay? Now, what about this? What if you divided 3 divided by 2 from the bottom to top? You get 1.5. Could you just put a 1.5 on bottom? Doesn't look as bad. You could. If you want to get rid of both of them, put a 1.5 on bottom. That's fine. But let's leave it. 2 stays, 3 stays. Whoa, hang on. Yeah, we got to the third power. Now, question here. I wish I would have addressed that first. Because I went ahead and started with 2 and 3. I went ahead and started on the inside. You have two options here. You have stuff to the third power. You can do one of two things. You can either go inside here, raise everything to the third power. What do I mean by everything? The 2, the a to the negative 3m, the 3, the a to the 2m minus 1. There's 4 things in there. You could raise all 4 of them to the third power, or you could clean up the inside, then raise it. That's what I suggest. Because then there's not as much stuff to raise to the third power. So let's go inside and let's clean it up, which I've already started doing that. You have a 2 and a 3. Let's leave those. Now here's the fun part. You have a to the 2m minus 1. You have a to the negative 3m. What do we do with those? I don't know the rule for that. It's ugly. Okay? So what do? I come over to the side and I say, well, what if it was this? Subtract them, right? There's 5 on bottom, 3 on top, or there's 5. We don't know. Is there more on top or bottom? I don't know. It all depends on what m is. So do I subtract from top to bottom? Do I subtract from bottom to top? Honestly, it doesn't matter. Where do you want your answer? If you subtract from top to bottom, you put your answer on top. If you subtract from bottom to top, you put your answer on bottom. It doesn't matter. Let's put our answer on top. So we've got this many on top. We have this many on top. We've got to take away what we have on bottom. You got to subtract negative 3m minus 2m minus 1. Now the other direction might have been a little bit nicer looking subtraction. Help me with this, Dalton. Negative 3m minus 2m. How many m's do I now have? Negative 5m. And here's where people will miss this problem. It's also minus 1, which is actually a plus 1. So how many a's do I have? I have a to the negative 5m. Start to make m's on this. Plus 1. It's all still raised to the third power. And I'll do this next step for you. I'm going to raise, there's now 1, 2, 3 things inside parentheses. I've got to raise the 2 to the third power, which is 8, not 6. I've got to raise a to the negative 5m plus 1 to the third power. A power raised to a power, simply multiply. How do I multiply? Distributive. So that's going to be a to the negative 15m plus 3. On bottom, 3 to the third power, 3 times 3 times 3, that is 27. And as you're writing that down, For those of you taking notes, as you're writing that down, I want to prove something that Logan helped me with a while ago. What if I would have subtracted the other direction? What if I would have done 2m minus 1 minus 3m? I believe that would be in 2m minus 1 minus would be plus 3m, which would have been 5m minus 1. And once you raise that to the third power, that would have been 15m minus 3. Look what it is on top, though. Negative 15m plus 3. So if I had have brought that to the bottom, would it have just changed the signs on each of them? Yeah. Okay, done with, that's your rules of exponents, done with that. I want to just start the next section just to kind of introduce it, and we'll pick up where we leave off tomorrow. What time did you say? 9:05? So we got about 15. That'd be pretty good. Give me about 5 minutes. Students will work problems involving rational exponents. Again, you might remember this from last year. That way I can just give you an introduction. You might get started on your next section of homework as well. 4 to the 1/2 power. We know 4 to the first. We know 4 to the second. We're good with all those. 4 to the third. We're even good with 4 to the 0. And we can now do 4 to the negative 1 and 4 to the negative 2. We know those are 1, 4, 16, 64. This would be 1 over 4 because you bring it to the bottom, and 1 over 16. But where does 4 to the 1/2 fit in? Well, I'd say that 1/2 is somewhere between here and here. It's between 0 and 1. If you actually had a number line, that's where it would fall. So how do you raise a number to a fractional exponent? A fractional exponent is simply another way of writing a radical. And again, there's certain things in math that amaze me how it connects. And to know that a fractional exponent, a fraction is the same thing as a square root. A 1/3 power is the same thing as a cube root. That just amazes me. And it fits perfect. I mean, 4 to the 1/2 power would be right in here. 4 to the 1/3 power would be right below it. 4 to the 3/2 power would fall between 4 to the first and 4 to the second. But here you go. Here's how you do this. Rational exponents, let me go back a slide. Here's how you rewrite it, rational exponents. If you have a number raised to, when I say rational, it's a fraction. That's all I mean by rational. Fractional exponents, or rational or fractional, the root word of rational is ratio. Ratio is a fraction, so that's the reason we call it rational. Here's how you rewrite it. It's simply a rewriting process, a lot like logarithms when we get to those. Whatever number is on bottom, if it's a third, 2/3, 1/3, 4/3, whatever it is, it can be rewritten as a radical with that index, a third root. Whatever number is on top is simply the power that will remain on that x. You can write it as the cube root of x squared, or, for the amazing use of math, you could also say the cube root of x all squared. You can do it either way. So x to the 2/3 power, the number on bottom is the root that you're taking. The number on top is what you're raising it to. So now these are easy. The one that we just looked at, 4 to the 1/2 power. The number on bottom is the radical that you're taking. If it is a second radical, second root, guys, that's a square root. We don't have to put that 2 there. So this would be a second root of 4 to the first power. 4 to the 1/2 is simply another way of saying the square root of 4, which we all know is 2. While I'm on this screen, let's go ahead and knock another one out. 8 to the 2/3 power. The number on bottom, again, is the radical you're taking, or the root that you're taking. This is a third root. And get into the habit. You can do these in your head. For those of you that will be math team, these are good ciphering type problems. They're quick problems to where you have to do something involving a fractional exponent, because really 8 to the 2/3, I would really like for y'all to get into a good habit of being able to just do it in your head. The bottom number is the radical you're taking, so it's a third root. So you've got to ask yourself, what number can I multiply by itself 3 times that gives me 8? And that number is? Thank you. The top number is what power you're going to raise it to. So I did the third root of 8, which was 2. Now we're going to take our answer and raise it to that top power. So 8 to the 2/3 power is 4. Again, if you looked at that on a number line, that would fall between 8 to the 0 power and 8 to the first power, because 2/3 was between 0 and 8. 8 to the 0 power is 1, 8 to the first power is 8. 8 to the 2/3 power, which would be closer, that's 4. 8 to the 1/3 power, a little bit closer here, that'd be 2. And you can see how that does fall in order on that number line.